All right, so in our last explainer on water balance, we talked a lot about ions like sodium and how absolutely crucial they are. Well, today, we're going to zoom out and look at the entire class of nutrients that sodium belongs to, the minerals. To get us started, here's a little riddle for you. What's the one thing that connects the structure of your bones, the blood flowing through your veins, and, yeah, even the battery in your phone? You guessed it, they all depend on essential minerals. Now, these are inorganic elements your body has to have to function. And here's something really cool that makes them different from vitamins. Since they're elements, like on the periodic table, they can't be destroyed by heat or light when you're cooking. They are incredibly stable. Okay, so when nutritionists talk about minerals, they usually split them into two main groups. And this grouping has nothing to do with which one is more important, because they're all important. It's all about a super simple rule, how much of them we need to get each day. First up, you've got the major minerals. The best way to think about these is like they're the main building materials for your body. You know, the bricks and concrete. We need a pretty hefty amount, specifically 100 milligrams or more every single day. And on the other side, we have the trace minerals. So if the major ones are the bricks, these guys are like the specialized high-tech power tools. You don't need a lot of them, but without them, the whole construction project just grinds to a halt.
So that's really the key takeaway here. It all comes down to that one dividing line, 100 milligrams a day. If you need more than that, it's a major mineral. If you need less, it's a trace mineral. Simple as that. It's all about quantity.
And here's the full lineup. You can see the major minerals on the left, the big ones like calcium, potassium, and sodium. Then in the middle are the essential trace minerals like iron and zinc. Now, I want you to pay close attention to calcium and phosphorus at the top of that major list. They are, by far, the most abundant minerals in our body, and we're going to be circling back to them real soon. So, okay, we know how we sort them, but what do they actually do? Well, all their incredibly important work can be broken down into 4 main jobs, kind of like a mineral's official job description. So here it is, their 4 main roles. They give us structure, they act as charged ions, they work as helper molecules for enzymes, and they become a core part of bigger molecules. Let's break each one of these down real quick. First, structure. And I mean this literally. They are part of what physically makes us, us. The classic example, of course, is calcium and phosphorus. They team up to form this hard, rigid crystal structure that gives our bones and teeth their strength. It's our body's framework. Second, they float around as ions, which are just atoms with an electrical charge. We already saw this with sodium ions and their role in fluid balance. Another amazing example is calcium ions. They are absolutely critical for kicking off the whole chain reaction that makes our blood clot when we get a cut. Third, a lot of minerals act as what we call cofactors. You can just think of them as an enzyme's little helper. See, enzymes are proteins that make chemical reactions happen, but many of them can't do their job until a mineral comes along, binds to them, and basically flips the on switch. And finally, number 4, some minerals are actually built right into the structure of bigger organic molecules. The perfect example is iron. Right at the very heart of every single hemoglobin molecule, the protein that carries oxygen in your blood, is an iron ion. That iron is what actually grabs onto the oxygen. No iron, no oxygen transport. Right, so we get these minerals from our diet, but it's not quite as simple as you are what you eat. When we're talking about minerals, it's really more like you are what you absorb. And that brings us to this really important idea called bioavailability. Bioavailability is basically a measure of how much of a mineral you eat actually gets absorbed and put to use by your body. Just because a food contains a lot of a mineral doesn't automatically mean you get all of it. A whole bunch of things can affect this. What's really cool is that our bodies are smart. They actually ramp up mineral absorption when we need it most. So during a big growth spurt in puberty or during pregnancy, the body becomes way more efficient at grabbing those essential minerals from your food. On the flip side, some things can actually block absorption. This happens a lot with plant foods. You have compounds like phytic acid in grains or oxalic acid in spinach that can latch onto minerals in your gut and prevent your body from absorbing them. And that's a big reason why having a varied diet is so important. So, to wrap it all up, it's pretty clear that whether we need a lot or just a tiny bit, minerals are these small but mighty elements that are absolutely essential for pretty much every single thing our bodies do to keep us alive. So now that we've got the general playbook for minerals, how we classify them and their 4 main jobs, we're ready to put a spotlight on the 2 biggest players on the team. That leads to the big question. If calcium and phosphorus are number 1 and 2, how do they actually work to build our body's foundation? Well, that's exactly what we're going to dive into in our next explainer.